and welcome, and in this video I want to talk about something called end behavior. And we're going to focus specifically on the end behavior of polynomial functions, and to do that I want to take a look at a couple of graphs first. Now if we look here, I have some polynomial function, okay? I could add a bunch of terms afterwards, but it really actually doesn't matter. End behavior of a polynomial function is going to depend on two things: the leading coefficient and the degree of the polynomial. Okay, so I'm going to make it a one-term polynomial, which is called a monomial, just to make things a little bit easier. And I'm going to kind of change these sliders. So the first thing I'm going to mess with is the exponent. So notice, as I change the exponent, the end behavior changes ever so slightly depending on what the exponent is. And by end behavior, I mean what's happening at the ends of the graph. So for example, what's happening at the left ends? Well, this one is going way down, 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 down. And what's going on to the right? This is going up, 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 up. That's what I mean by end behavior. So notice it changes for some of them, but actually some of them are the same. If I compare a couple of these, notice that when the exponent is 10, that actually looks very similar to when the exponent is 8, or when the exponent is 6, or when the exponent is 4, or when the exponent is 2. And that's because all of those exponents are even. So if you look, whenever the exponent is even, the end behavior is the same in each direction. And it didn't matter if I change this to 100. The end behavior, notice it is going way up at each end. However, if the exponent is odd, so if I notice if the exponent is 1 or 3 or 5, 7, 9, 27, so on and so on, the ends are actually pointing in opposite directions. So as to the right, we're going up, and as we're going to the left, we're going down. So one thing that you can take away is that if the exponent, or excuse me, if the degree of the polynomial is even, the ends will be pointing in the same direction. Notice both of these are pointing up at the ends. Both of these are pointing up at the ends. Both of these are pointing up at the ends. And even if I were to change my leading coefficient to something like 5 or -3, notice it's pointing down, but they're both pointing down now. Or -7, both pointing down. That if the degree is even, you'll be pointing in the exact same direction. However, if the degree is odd, something like 3 or 5 or 7, the ends are pointing in opposite directions. So that's regardless if a is some positive number like 1 or 6 or 12, or even if it's a negative number like -2. Notice it's flipped, reflected, but they're still pointing in opposite directions. And this leads us to a topic of end behavior and how we can determine the end behavior just based off the equation. Now, when we had a function that had an even degree and a positive leading coefficient, so I'm going to call that kind of a positive even, it pointed up in each direction. For example, if it was like x squared plus 2x minus 3, or 4x to the 6th minus 2x plus 16, that would be a positive even with a positive leading coefficient and an even degree. They'd be pointing up in each direction. But if I had a negative exponent, or excuse me, a negative leading coefficient, not negative exponent, that's something else entirely, but if a negative leading coefficient and an even degree, they were pointing down in each direction. But notice they're both pointing in the same direction. It's just that if it's a positive even, it's going up. If it's a negative even, it's going down. And then if we had a positive leading coefficient and an odd degree, it was going down to the left and up to the right. But if it was the opposite, if it was a negative leading coefficient and an odd degree, it was actually going up to the left and down to the right. And this is the end behavior of all polynomial functions. Every single one is going to boil down to one of these four. So if I gave you guys a function, something like f of x is equal to 3x to the 6th minus 2x to the 5th plus 3x minus 2, I can determine exactly what the end behavior would end up being. And for this one, I have a positive leading coefficient and an even degree. So I know it would look like this at the ends. But we also need to be able to actually write out what the end behavior is. And it's always going to look like something like this. As x approaches negative infinity, what does y approach? And as x approaches positive infinity, what does y approach? This is always going to be the setup for end behavior for most functions, all polynomial functions. And if I look at this, this would be a positive even. This would be a positive even because it has a positive leading coefficient and an even degree. The degree would be 6, which is even. It would look like this at the end. So it would be going up in each direction. So as we go to negative infinity for x, basically what that means is as we go further and further and further to the left, it would be going up. So y would be going up to positive infinity. And as x went to positive infinity, as we go to the right, it would be going up to positive infinity. And that's actually how we're going to be writing the end behavior. Okay, so let's take a look at just a couple more. So if I look at this one here, this has a negative leading coefficient, and the degree of the function is 3, which is odd, so this would be an example of a negative odd. And that end behavior looks like this, up to the left and down to the right. So we would once again write our end behavior as x approaches negative infinity. What does y approach? And these are just arrows. In math, that just kind of means approaches. And as x approaches positive infinity, what does y approach? Well, as x approaches negative infinity is as we go to the left. Well, notice for a negative odd, notice as we go to the left, we're actually going up for y. So y would approach positive infinity. And as x approaches positive infinity, so as we go to the right, we are heading down to negative infinity. And once again, notice that when we had an even, both of the y's were the same. When we had an odd, both of the y's were different. That matches up with the graph. If you have an even degree, the ends are going to be pointing in the same direction, which means they're both going to be positive infinity or both negative infinity. Or if you have an odd degree, they're going to be different. One y will be positive infinity, the other will be negative infinity. That's always going to be the case. So this would be the end behavior of a negative odd, such as this function here. Let's take a look at maybe one more. So if I look at this one here, for example, I have a negative leading coefficient, and the degree of the function would be 2, which is even. So this would be an example of a negative even. And as we can see, a negative even looks like this at the ends. And once again, because it's an even degree, it is pointing in the same directions at the ends. Both of these are pointing down. So if I wrote the end behavior, once again, as x approaches negative infinity, what does y approach? And as x approaches positive infinity, what does y approach? Well, if we look in both directions, it is heading down. Both ends are heading down. So both of these would end up being negative infinity. So once again, notice if the degree is even, either both are going to be positive infinity or both are going to be negative infinity. If it's odd degree, it's going to be different for each y. So let's take a look at one last example. It makes sense to cover 4, right? Because there's 4 possibilities. So let's cover that 4th possibility. So last example, we have f of x is equal to 6x to the 5th plus 2x squared. Well, once again, this would be a positive leading coefficient and an odd degree. The degree would be 5, which is odd. So we have here a positive odd. And remember, since it's odd, it's going to be pointing in different directions at the ends, and it's going to be this one here. So one y will be approaching negative infinity, and the other y will be approaching positive infinity. And we write that as x approaches negative infinity, what does y approach? And as x approaches positive infinity, what does y approach? Well, as x approaches negative infinity, it is going down to the left. As we go to the left, it's going down. So as x approaches negative infinity, y will also be approaching negative infinity since it is going down. Whereas if x approaches positive infinity, so as we go to the right, y is going up. It is increasing, so y will also be approaching positive infinity. And that is end behavior, guys. I know it looks daunting, but it's really not that bad. As long as you know positive even, up in each direction, negative even, down in each direction, positive odd, up to the right, down to the left, negative odd, up to the left, and down to the right, that's really it. I hope this video was helpful. If there's any questions, please feel free to let me know. We are going to be using this a lot once we start talking about graphing polynomial functions. So if there's any questions, reach out, let me know. Otherwise, I look forward to seeing you guys in the next video.